Welcome to Ask and Learn.
For the domain, we know that x is all real values. Intercepts, if we substitute 0 in place of x, we see that y is 0, so 0, 0. And we can factor this out and get x to the 2/3 x minus 5 equals 0. So here we're setting y equals to 0. And we see that x can be 0, we already have that, or 5, so 5, 0 is our other intercept. And there is no symmetry to this graph. And there are no asymptotes because it's not rational. It's not a rational function. Next, for increasing and decreasing values, we find y prime. That's 5/3 x to the 2/3 minus 10/3 x to the negative 1/3. So y prime, if we factor this out, 5/3 x to the negative 1/3 x minus 2. So we see, if we set our first derivative to 0, we see that x is 0 or 2, so our critical points are 0 or 2. If we make a line graph for f prime, and we plot our critical points, and we test values around our critical points in the first derivative, we see that we'll get positive values for less than 0. Between 0 and 2, we'll get negative, and anything greater than 2, positive. So it's increasing and then decreasing around 0. So this is a max, local max, and we have a local min because it's decreasing and then increasing. So this is a local minimum value. Next, we're going to test for concavity. So if we already have our first derivative, now we can find our second derivative. Y double prime is equal to 10/9 x to the negative 1/3 plus 10/9 x to the negative 4/3. We can factor this out. Y double prime equals 10/9 x to the negative 4/3 x plus 1. So here we have x equals 0. If we set this equal to 0, we have x equals 0 or x equals negative 1. So we make another line, but this time it's for f double prime. And we're testing values around negative 1 and 0. In our second derivative, here we have negative, positive, negative. So the negative will give us concave down, positive concave up, negative concave, I'm sorry, this is positive, so this is concave up as well. So here we see that there is a sign change, which means that at 1 there's an inflection point. So now we can graph it with the information that we have. So here we have intercepts at 0, 0, and 5, 0. So 0, 0, and let's call this one 5. And we have a local min at 2, so let's say this is 2. And we have an inflection point at negative 1. So let's call this negative 1. And now let's find the y values. So if we see where f of 2 is for our minimum value, we can say it's approximately negative 4.8. So this is negative 4.8. And we can say that's where our local minimum value is. Our maximum value is at 0, 0. We already know that's an intercept. And we have an inflection point at 1. So here at negative 1. So at negative 1, it's going from concave down to concave up. So concave down, and the second we're at negative 1, it switches as an inflection to concave up. And now at our intercept here at 0, 0, between 0, 0 and to negative 4.8, we see that it goes concave down. So let's draw concave down. And then when it goes back up to our intercept, anything beyond 2 is going to be concave up. So it's going to be concave up, hit the intercept, and go up. And this is our graph.